Okay, question on number 65 here on 2.4. These problems tend to bother people because the directions are just asking you to come up with a graph that does these things. So this is what's considered an open-ended question. There's not just one right answer to this. So your graph might look very different from my graph, might look different from a friend's graph, but it's got to have a few things in common right here. First thing they're telling us as I read the directions is that f has to have a removable discontinuity at x equals 1. Now remember, guys, a removable discontinuity is one that we would just consider to be a hole. So we've got a hole at x equals 1, a jump at x equals 2, and then we've got this information about what's happening at x equals 3. So there's a lot going on here. You could really put that hole anywhere you wanted here. So at x equals 1, I'm just going to go ahead and put an open dot right over there. Maybe at the point 1, 3. Nothing else dictates what has to happen to the left of that graph. So I'm just going to make this thing do something different over there, and there you go. I think we're all set. Now, in order for that to be a hole and not just a jump discontinuity, this function has to have the same limit as x approaches 1 from the right as it does from the left. That means that I have to continue out of this hole from that same point there and now go somewhere else to create a jump discontinuity at x equals 2. So as I get towards x equals 2, I'll go ahead and put, and I think this could be really either a closed dot or an open dot right here, but it would need to be one or the other, but not both. So I'm going to go ahead and put a closed dot. And you'll notice I'm not really paying any attention at all to the y value of this point. I don't care that much. To have jump discontinuity at 2, I'm going to have it go somewhere else, maybe like right about here, just guessing here, and let's put an open dot maybe at the point 2, -1, and there's our jump discontinuity. Now the tricky part here is our limit as x approaches 3. As it approaches 3 from the left, our limit is -infinity. And as soon as you see an infinity right here, guys, that tells you that we are dealing here with a vertical asymptote at this spot right here of x equals 3. Now notice, we have a finite limit as x approaches 3 from the right, and usually when we see a vertical asymptote occurring naturally, your limit is either infinity or -infinity on both sides. So this is pretty clearly kind of a contrived function, guys. I can't think of one where this would happen naturally, but let's do what they want us to do. I'm going to go ahead and put the vertical asymptote right here at the line x equals 3, and focusing on this part right here as x approaches 3 from the left, our function needs to have a limit of -infinity, meaning that it is decreasing without bound, so I would probably make it do something like that. And the last thing I need to cover is this statement here then. The limit as x approaches 3 from the right would have to be 2. So that means we're going to hit the point 3, 2 right over here, and as I think about this, I don't think it matters whether this is an open or a closed dot right here. So I'm going to have that, and then again, this could do almost anything on the right-hand side that it wanted to. I'm just going to make it look like part of a rational function, maybe there, looking something like that. So this would be my graph here for y equals f of x, and let me just double check now that it does everything that it needed to. We were supposed to have a removable discontinuity or a hole at 1, and I think I've got that part right here. The second thing I guess I could have labeled that number 1. The second thing I was supposed to have was a jump discontinuity at x equals 2, and sure enough, my left-hand limit and my right-hand limit are different values. And the third thing it needed to have were these limits here as x approaches 3. From the left, our value was supposed to be going down towards -infinity, and it was. And from the right, we were supposed to be approaching a y value of 2, and there we go. So once more, an open-ended question. Not everybody's answers are going to look exactly the same, but this graph does the things that this function was supposed to do in number 65.